name is Cosmin Stanchu. I'm working for Adobe, and I've been with Adobe for the last 4 years now. It's actually the same amount of time that I've been in the Bay Area, 4 years. A few words about me. I was born in Romania, and back in the day, Romania was a communist regime, and I remember like this day, like the places where I used to live, they looked like, you know, the images from the Chernobyl series. And everything was scarce back then. You know, you had shortage of food, shortage of, you know, electricity. Warm water was just once a week. But personally, I did have a good life. My parents were, you know, pretty nice people. I don't know if you can believe it, but that's me right there. I think my mom wanted a girl, and I have no idea where the hair went. But had a loving family. I constantly remember my dad, you know, telling me to shut down the door or close the door because the, you know, the heat will run out or go out. And it will also tell me that I have to turn off the lights when I'm not using them. Keep the lights on only when you need them. That was his constant, you know, indication that he would give me. Over the years, this kind of actually stuck with me, and it made me realize that actually resources are limited. And things that you might use, someone else might not be able to use those just because you're using them. And this is a good relationship with my presentation today, and a good concept because serverless is doing exactly that. Serverless will allow you to, if a particular function is not being invoked, then that function will not be deployed onto the cluster. So that means you can keep the lights off in case you don't need them. I work with Adobe I Runtime team, and Adobe I Runtime team is part of a bigger team, which is the Adobe I/O. And the responsibility of this bigger team is to provide a platform for developers so that they can extend Adobe products. And my team, the Runtime team, is the one that makes sure that those developers don't have to care about servers. So Adobe I Runtime provides a serverless platform on top of the Apache Openwhisk. And maybe some of you know that Apache Openwhisk is an open source project that has been started by IBM a few years ago, and it has many contributors right now, many of them being from Red Hat, other companies, and also Adobe. And two of those contributors are part of the Adobe, and they're with me right now. So all the complicated Openwhisk questions that you might have at the end, just point them there. But Openwhisk as a platform uses events to drive the execution of stateless functions. And the cool part and the good part of this is that the developers have the option of selecting or using a multitude of languages. That means that you can write your function in JavaScript, you can write your function in Java, or even in PHP if you want to, because at the end of the day, what happens is this function will be packaged into a container and it will be deployed in your cluster. So today, I would like to present to you 4 reasons why. 4 reasons why serverless is maybe something that you should be considering using into your productions environments. And 4 reasons why, for a developer, the experience is greatly improved. And I will exemplify today on how easy it is to develop with serverless. But before I go on, I would like to ask you how many of you here are using serverless in your productions environments today? I see 1, 2, 3 hands, 4, with Adobe included. So I guess like the presentation today is for most of you. just because, you know, serverless is a technology that really helps developer to move faster. So, let's start. The first reason why, and there are many others, but these are, for me, the most important ones. The first reason is the reduced operational burden. And what it allows a developer to concentrate on delivering business value, which is the most important thing, right? I don't want to care about anything else. I don't want to care about deployments. I don't want to care about servers or VMs. I just have to deliver business value. And this brings us to the cognitive load that is, you know, you're having your developers in case they have to be part of the multiple processes. And in this case, that's not the case. In other words, I would say, just concentrate on whatever is sparking joy. And I know I'm a developer, so for me, what sparks joy is actually the function. But everything else that is related to scaling, provisioning, idleness, failover, you know, even the containers, if you can imagine in a microservice world, even the containers are not part of the things that are sparking joy for me. So as Marie Kondo would say, let's just thank them and take them out of our closet. The second reason why I think this is something that you should be considering is ease of development. And I have heard this term actually to this presentation here and some other presentation about the low TTFHW, which in translation would mean low time to first hello world. And for a developer, that's really important. How fast I can deploy my first function, because that will definitely impact, you know, my adoption interest for that particular technology. And I can tell you today that for actually writing, deploying, and executing the function, it's whatever you see right now on this screen. It's a JavaScript function that returns the hello world. And then you can execute a CLI command, in this case it will be the Whisk CLI command, to create the function with a path for that particular JavaScript function, and then a name for it. And then you can invoke it 1,000,000 times if you want. Once that function has been created and deployed on your cluster, that's the moment when you execute it as many times as you want. Another interesting aspect about how easy it is for a developer to adapt this type of technology in the framework would be how much time do I have until I need to deploy my function to a dev or a stage environment. Can I develop everything locally? And I can tell you today that you can. There is this concept of Openwhisk in a box, or Openwhisk standalone version. That means that you can take the power of Openwhisk that runs in a cloud. You can execute it with just one command, that's a jar file, which will spin up a lot of, you know, applications, containers for you. And at the end of the day, you can actually run your function locally, and you can deploy it locally. And you also have like a playground here where you can play with many examples that you would like to test. So next time when you decide to go kiteboarding on a remote island where the internet connectivity is low or is bad, then you can just have that on your local machine, because you don't need the platform, you don't need a connectivity to the internet so that you can develop your functions. For me as a developer, another important aspect is debugging. And debugging of a function that runs into the cluster is pretty easy. And I'm going to have an example later on demonstrating how this can be done. Maybe one reason why developers would not like to take in consideration of using serverless is because you have to deal with a lot of complexity once the relationship between your functions or your application is more complex. Because if you think of a monolithic application and then, you know, going to the microservice and then going to the function, in order to have a whole application, you need to find a way of gluing all those pieces together. So how can you do that with serverless, and in particular with Openwhisk? Well, there are two main important concepts that I'm going to talk about this today that will help you to piece all these puzzles together. So one of them is the simplest one, which is a sequence. And a sequencing is similar to the piping in a Unix system, where the output of one command is actually the input of a different command. This is exactly what's happening here. You have function A and function B, and the output of the first function is going to be the input of the second function. So this is being created in Openwhisk just by running one single command where you define the sequence between those two functions. A more complex approach is the composer. And the composer is a programming model for building serverless applications that composes functions, APIs, and services. And you can write code to express the control on the data flow. What this means is that once you have written your function A, function B, function C, then you can write a different function, it's going to be function alpha, that contains the code on how you can piece all these functions together. It means that you can say, okay, if the response of the function A is going to be this, then invoke function B or function C. And it can go even more complex. So at the end of the day, you will have the same capabilities that you have running your application or developing your application into any other language. What about debugging and monitoring? Well, for debugging, you already have out-of-the-box integrations with Splunk or Elasticsearch, and I will exemplify how easy it is to get the logs for your activation or for your execution. But at the same time, you get out of the box with Openwhisk and with our platform, a UI and a dashboard that will give you information on how many executions did you have, how many errors were part of those executions, how much time did it take for one execution to happen, how much time did it take for a container to spin up. So you can separate into multiple values that you can analyze, not important for any developer. Let me give you two examples tonight of the first one would be how to create a function, how easy it is to deploy it and execute it. And the second one would be on how you can debug a function, not on your local machine. Actually, the code is going to be on your local environment, using whatever IDE you would like, but it's going to be executed and the function is running actually on the cluster. So, as you can see here, I have my hello world that I used earlier. I would just add a console.log in order to be able to log some messages, and you can see how I can extract them. And then I will create my action. This time the action has been created and deployed. And I can invoke the action, and I can execute it now as many times as I want. Once those actions have been executed, I can have a trace and I have a list of the actions that have been executed, and I can find that identifier in order to get my logs. And as you can see, the output here is the log message that I have created into my function. Then I can go into my dashboard and I can see how many executions have take place. In this case, it'll be 5 because I executed a few before that. And you can go and see how many activations, executions have been, successful. How many errors did I have? I can see the duration of those executions, and I can go into detail of seeing what was the duration or the initialization of that function or the wait time. So I have a UI for everything with Openwhisk. The second example that I want to present is a web action that is actually rendering a web page. So what it does, it has an input of of a name, and then it renders whatever comes from that input into an HTML page. And I already set my breakpoint there. I'm going to execute it. And as you can see, my breakpoint has already been activated, and now the variables that have been set there can be viewed in the debugging environment. Another cool feature about this is that you can actually hot deploy this by just changing something into your function, and immediately those changes will be deployed into the browser. So you don't even have to manually reload the page. And if you look here, you will see at the top of the page, the URL is actually the URL of our cluster, is nothing running locally. So you're actually debugging whatever you have deployed on the cluster. This is a project that has been created by another colleague of ours. It's not just our team contributors, but any other teams that would like to improve the project in a different way can write this type of applications that will improve the experience of a developer. So I think this speaks a lot of how important it is for us in this case to help developers to be very efficient into the way they develop and to make their life easier. The third reason why would be never pay for idle. And this takes me back to my introduction, where I was saying that it's important that you don't have to keep the lights on when you don't need them, because the only time when an execution or a function is going to run in your system is the moment when you invoke it. If it's not invoked, then that execution or that function will not run there. But you'll ask yourself, okay, you said that every function is being packaged into a Docker container. But in order to trigger or to spin up a Docker container, it takes some time, like sometimes it could take seconds. How do you deal with the first starts of that particular container? And I will tell you how we deal with performance in Openwhisk and in Runtime. So the first one would be resource reuse. That means that once a container has been started and once the function has been executed, then that container will be there for a period of time so that the immediate requests and everything that is coming, all the requests that are coming after, will hit an already existing container, so you don't have to start a new one. But what do you do with the first request that is coming? Can you improve the performance of the first execution? And there is this principle that we have in Openwhisk, which is related to stem cells. And this allows you to deploy or pre-create some containers that have no code, but they only have the runtime in it. So for example, if you will be executing a JavaScript function, you will select or pick one of these containers that is already deployed, already there. It will inject the code, and then only after that, it will make a call to that container. And you can decrease actually the time from 2 seconds to 10 milliseconds for the first request. Another way of improving the performance of the system is using caching. And caching is something that everyone is using in front of a microservice also, but you can use that with a serverless technology also. So what we do, we put a caching in front, and the moment you're making the request, the first request will be retrieved from the platform, but then all the other requests will be retrieved from the cache. And the developer has the flexibility of defining how long he wants to have that cache available, and which requests should be cached and which requests should be not cached. The fourth reason why is scale with usage. So every time a load is coming to your function, the system will automatically scale up, and it will add new containers if it's required to do so. There is an interesting concept that has been developed actually here by Adobe, by Tyson, who was the main contributor, of providing a concurrency for that particular action. That means that for your action, you can define a concurrency of 10, let's say. That means that all the 10 requests that are being sent in parallel are going to hit one single function and one single container. If 20 requests are coming to the system in parallel, then 2 containers are going to be spin up and you can send them there. If the concurrency is 1, then every request that is coming is going to spin up a new container. So that gives more flexibility to the developer on to tailoring the way the execution is going to happen in the cluster. Of course, it depends on the application itself. If your application logic allows concurrency on that action, but if it does, it's much more performant and you can use this. Maybe the next question will be, okay, but you're saying that you can spin and you can create so many containers, but what about the underlying infrastructure? You cannot have infinite, resources. How do you deal with that? And there is a project in place, also in Openwhisk, and my colleagues have been working on that in order to look at the capacity that is available on a cluster and make decisions on how to scale up or how to scale down the cluster in terms of what is the load of that particular node on the cluster. And the next step would be to apply machine learning to look at the history of the data and make predictions on how the capacity of a cluster should look like for the next minute or for the next hour. And this will go even further into optimizing the cost and optimizing the resources that you're using in one cluster. I would like to talk now about a few examples and how clients and customers of Adobe are using this serverless technology in our case. And the reason, there are multiple types of workloads that right now are using Runtime, but I chose these two just because they are completely opposite. Because one is non-real-time and the other one is real-time. There is this idea that serverless is actually only for batch processing. And what is actually meant for is to only trigger workloads where the response time is not important. And I would like to show you today that's not really the case. In our case, even web pages where the experience of the user is really important are using serverless. But let's start with the first example. The first example is the asset compute service, which, in other words, it deals with processing images. So imagine that someone is uploading an image that is in a big in size. It can be a Photoshop file in some cases, and you would like to transform that image, and you want to have multiple renditions for the image. But at the same time, maybe you would like to apply some kind of artificial intelligence to it and understand what is happening in that image, apply a title, or maybe add tags for that particular image. So you're calling Sensei Service, which in Adobe terms, that is the AI team that is providing all these services for doing artificial intelligence on images. So in this case, every single rendition and every single resize of that particular image, also, the call for the Sensei service, everything can be done in parallel, and it can be a function. So at the end of the day, when you're done with the entire workload, then you can generate an event that everything is done. All the assets will be uploaded to the cloud, and the workload is done. I will address this question. If you have to process a million image at the same time into multiple regions, how would you solve that problem? And it might be that in the end you could realize that the only solution to do so could be something that mimics what serverless does. My second example is Adobe.com, and what Adobe.com does is accessing CRM data using serverless in order to personalize the experience of the user on the page. And of course, the response time is paramount. It's really important, because if the response doesn't come in time, then your experience on that page will be impacted, and you don't want to have that. So in this case, you might go on adobe.com, and depending on the country or depending on different parameters, you might get a different product or something different on the page just by executing serverless. Lessons learned. What have we learned on our journey having this, working on this project? So one important aspect of this is you should concentrate on security from the beginning. And the way we're doing security in this environment is by having Dockerizing every function, and then deploying it into Openwhisk. Then you need to have strict network policies that will take care of the communications between the containers or the communication with the outside world. These have to be applied to your network. Encryption is important too, so that in the eventuality of one container or someone escaping from one existing container, then nothing can be read from the others. And interestingly enough is that Adobe offers this platform to internal customers. And the internal customer, you're trusted. You will expect that they don't push anything that is has code that is untrusted. But it also offers this platform to external developers. And there, the validation of the code is not that strict. So, but we don't have multiple clusters for that. It's one single one. So that means that we treat the internal and external as the same. And this brings me to another concept that is important here, and that is we should not use gates bar guardrails. Because if you do that, you'll be able to provide the same system to everyone. Just make sure that your sandboxing system is, secure enough so that you can run everything in there. But many of you will definitely have this question: why did Adobe decide to go with Openwhisk, or decide to have its own serverless offering when there's so many right now? Like, you have AWS, you have Azure, Google, everyone has a serverless as a service at the moment. And why didn't we use one of them? Well, the first and the foremost would be flexibility. What having your own environment gives you is the ability to be, multi-cloud. So right now we have our serverless platform offered in AWS, but we're working to provide that also in Azure. And from a developer's perspective, nothing has changed. It's exactly the same CLI. If they don't want to know, they don't have to know that actually that particular function is executed now in one cloud or another. But if you do want to know, then you can select your cloud of preference where you have your data, or so that those workloads are executed close to your data. Another reason why is we have control over the Openwhisk runtime images and the Openwhisk packages. And what this gives us is even more improvements and more ease of development for the developers. Why? Because there is one dedicated team right now at Adobe that is working on improving the experience of developers by providing SDKs. That means that if you're writing a function and you want to integrate with any of the Adobe products, you don't have to write REST calls or access APIs and write that code all over again. We just, execute one of the existing functions that are already there, and you can call that service. The same with authentication, authorization. We already know who you are. So why write code in order to authenticate yourself to various other services? We can provide that out of the box for you. So that means we're developing it once, and you can just have it as a feature. So this is really important. Do whatever it takes in order to improve the experience of developers, because at the end of the day, they are going to benefit because of that. I think this is just the beginning of the journey, Adobe's journey to create a serverless platform, and I'm pretty excited to be part of it. so that our developers and whoever uses this platform will have a great experience and can deliver business logic faster, and at the same time would be able to keep the lights off when they don't need them.